So let's talk about how to do these intervals by hand. If we're doing these by hand, we would say again that we're using T's because we do not have sigma. So we'd be starting out with how do we do T's, which is saying, oh, I need to find the margin of error formula, which would be T sub C S over the square root of N. Well, we know what was given in the problem is that our S was on top here is 4.8 pounds. We know that our N is 40. So we'll have a square root of 40 on the bottom. And the thing that we're worried about is finding our T sub C, our critical value. Well, if we're doing this by hand, I'm going to start by drawing a picture to find the critical value. And remember, this is going to be based on our confidence level, which according to this problem, our confidence level is again 0.90. So that would be the area in the middle. And then you can do one of two things. You can use your calculator, or you can use your table, your T-table, to find your critical value, T sub C. Either way, you're going to need an area to the left. If we've got 0.90 on the middle, that means each end is going to be the 0.5. We've done something just like this before, which means the entire area to the left is the 0.90 and the 0.05 added together, which is 0.95. So you can do one of two things. You can use your calculator using the inverse T and use your 0.95 we just came up with. And comma, your degrees of freedom has to go in last. Remember, your degrees of freedom are your n minus 1, which in this case would be, our n was 40, so this would be 39. And so you would use your calculator for that, and you'd get a value of 1.685, roughly. And this is your critical value for T. Or you can use your table, and your table gives you degrees of freedom of 39. An area in one tail of 0.05 or in both tails of 0.10 gives you a T value or critical value of, using your table, same value, you'll get T sub C equals 1.685 either way. Then whether or not you did that using your calculator or the T distribution table, then you can go back to your error formula, the T sub C over times S over the square root of N. We just found out our T sub C, our critical value, was 1.685. And then we found out our S wasn't given in the problem. That was 4.8. Divided by the square root of N, and N was 40. So that would be the square root of 40 on the bottom. And then we would go ahead and figure out what the 1.685 times the 4.8 divided by the square root of 40 is using our calculator. And what we'd get is roughly 1.28. And that is your margin of error that you would then use to come up with your confidence interval. How would you come up with your confidence interval? Remember, your confidence interval is two-sided with your mean in the middle, and your mean for this one, going back to the original problem, was 2.1. We just found out that the error was 1.28, so we'd be taking the mean, the 2.1, and adding the error to get the top end, adding the 1.28, which would give us the 3.38, which would 3.38, would round to our 3.4 if we round to the tenths place for that top number on our interval. And then the lower end would be the 2.1, the mean, minus the 1.28, which would get us the lower end, which would be the 0.82, which rounds to the 0.8 we came up with. So our confidence interval would indeed be the same. Our confidence interval for the mean, mu, would end up being 0.8 to 3.4. And again, this is in pounds just like before, and this is done by hand this time. Okay, the last type of problem we're going to look at is the problem using the minimum sample size formula.